Imagine standing on the surface of Mars. The sky above you is a faint, dusty pink, and the barren landscape stretches endlessly in every direction. Today, Mars is a dry, desolate world, but it wasn't always this way. Billions of years ago, Mars had rivers, lakes, and perhaps even oceans. What happened to all that water? Understanding why Mars lost its water is one of the most intriguing questions in planetary science. To answer this question, we need to journey back in time to the early history of the solar system. About 4–5 billion years ago, Mars formed from the dust and gas left over after the Sun was born. During its first billion years, Mars had a thicker atmosphere and warmer temperatures, conditions that allowed liquid water to exist on its surface. Evidence of this watery past is etched into the Martian landscape: dried-up river valleys, ancient lake beds, and minerals that form only in the presence of water. So, what changed? Why did Mars, once a potentially habitable world, become the cold, dry planet we see today? The primary culprit is the loss of its magnetic field. Earth's magnetic field protects our atmosphere from being stripped away by the solar wind, a stream of charged particles emanating from the Sun. Mars, however, lost its magnetic field around 4 billion years ago. Without this protective shield, the solar wind began to erode Mars' atmosphere. Over millions of years, the once thick Martian atmosphere was gradually blown away into space. As the atmospheric pressure dropped, water on the surface could no longer remain in liquid form. Instead, it either evaporated into the thinning atmosphere or froze into the ground in polar ice caps. NASA's MAVEN mission has provided valuable data supporting this theory, showing how the solar wind continues to strip away the remnants of Mars' atmosphere even today. Another factor contributing to the loss of water on Mars is its lower gravity. Mars is only about half the size of Earth, with roughly 1/3 of Earth's gravity. This weaker gravitational pull made it easier for water vapor to escape into space. Combined with a lack of a magnetic field, this meant that any water in Mars' atmosphere was destined to be lost over time. The transformation of Mars from a wet, potentially life-supporting planet to the arid world we see today serves as a powerful reminder of the delicate balance that sustains life on Earth. It also highlights the importance of studying other planets to understand the processes that can change a planet's habitability. Today, missions like the Perseverance rover and the Mars Reconnaissance Orbiter are searching for clues about Mars' past climate and the possibility that life once existed there. By studying the geology and chemistry of the Martian surface, scientists hope to piece together a more detailed history of water on Mars and answer the ultimate question: could life have ever thrived on the red planet? As we continue to explore Mars and other worlds, we gain not only a better understanding of our celestial neighbors, but also a deeper appreciation for the precious, life-sustaining conditions here on Earth. Mars' story is a stark illustration of how planetary environments can change drastically over time and how crucial it is for us to protect our own planet's delicate atmosphere and climate. In conclusion, Mars lost its water due to a combination of factors: the disappearance of its magnetic field, the relentless solar wind, and its weaker gravity. This cosmic detective story underscores the importance of planetary science and exploration, reminding us that while the fate of Mars was sealed long ago, we still have the power to influence the future of our own planet. Let us heed the lessons of Mars and strive to preserve the precious gift of water that makes life on Earth possible.